We're going to learn now how to take the derivative of a composite function using something called the chain rule. But before we talk about taking the derivative of a composite function, I want to do just a couple warm-up problems. Um, and so here are two problems. I want you to find their derivatives. So I want you to pause the video, find the derivative, and then unpause it to check your answer. So for the first one, we notice that it's a power rule, so y prime, and we've got a constant, so it's constant times the derivative of the function. Uh, 8 drops down, x to the, now it's 8 minus 1, so we get 32 x to the 7th. That's the derivative. Next one, we've got an exponential function and a constant in front, so the derivative is 4 times, well, the derivative of an exponential is ln of the base times the exponential function. So that's our derivative there. What about a slightly trickier one, though? Pause the video and take a second if you can think about how you might do this. And my hint or my the common mistake is thinking that you can just treat this um, as a normal exponential, but you can't. You know, a normal exponential needs to be base raised to an x, not plus things. So pause it, see what you can do. All right, so the trick to this is to re-express this as y equals 4 times 4, or we're cleverer than that, as 4 squared times 4 to the x. Because we know that, using our exponential rules, this is just 4 times 2 plus x, or x plus 2. But by rewriting it like this, then we get y equals 16 times 4 to the x, just a constant times an exponential. So it equals 16 times ln 4 times 4 to the x. But we're going to learn how to do a problem like this using the chain rule, which is the new method for today. So we'll learn another way to get to this exact same derivative. Okay, so before we start talking about what the chain rule is, we just need to remind or remember about composite functions. And this is, you spent some time in the summer work thinking about composite functions. So, if we wanted to think about this as an inner function and an outer function, so let's, say like um, a of x and b of x, where this is really a of b of x. Um, what would be our inner function? Well, our inner function is the innermost function, 3x minus x squared. And our outer function, well, we're squaring that. It's something, it's our something squared. So our a of x is x squared. So um, this function here, we could think of as the composition of a of b of x. Because if we were to stick b of x into x, we would get 3x minus x squared squared. Exactly the same thing there. Okay, well, what's in the next one, what would be our outer function? Sorry. What would be our outer function and what would be our inner function? Well, our inner function is this sine of x. And our outer function is e to the x, such that a of b of x, if I were to stick b of x into all the x's for a of x, so in other words, a of sine of x, where sine of x is b of x, equals e to the sine x, which is what we have there. So what we're going to need to be able to do is take these composite functions and figure out what's the outer function, what's the inner function, what's the composition of these functions. And this is a skill that you've done in pre-cal, you know how to do, but now we're going to add some calculus onto it. The calculus is this, the derivative of a composite function. So the derivative of f of g of x. And the con videos that I'm going to have you watch are they write it slightly differently than I do, but I'm gonna write it the way that I think is the most appropriate. Um, and the derivative of a composite function is the derivative of the outer function with the inner function still in it times the derivative of the inner function. So the derivative of the outer composed of the inner times the derivative of the inner function. And just to extend this beyond a two function composition, I mean, if I had f of g of h of x, the derivative of this would be the derivative of the outer with the inner still in there, so g of h of x. And then working sort of outside in um, times, now we're going to multiply. So we've already taken the derivative of this. Now we're going to take the derivative of that. So times g prime of h of x. And now we're going to take the derivative of the last, so times h prime of x. Um, and and for the beginning part, take this slow, and within a day or two, you're going to be able to do these very quickly. So let's go through how h of x. We said the outer function f of x is x squared. The inner function g of x is 3x minus x squared. Well, then we can find f prime of x, which is 2x, and g prime of x, which is 3 minus 2x. And so, using this chain rule, f prime of g of x times g prime of x for this given function would be 2, but instead of an x, I'm substituting in g of x. So 2 times 3x minus x squared times g prime of x, 3 minus 2x. And looking at the other one, so e to the sine x, well, my outer function is e to the x, my inner function sine x, f prime of x is e to the x, g prime of x equals cosine of x. So f prime of g of x, so e to the g of x times g prime of x. That would be this is my derivative right here. Now this starts getting a little bit, it gets a little bit tricky because we have these multiple terms or multiple factors, and it starts expanding and it starts getting ugly. But really, 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 as long as you can keep this rule straight for the beginning, it's very formulaic, and after maybe 10 or 20 times doing these problems, you're going to start seeing very easy ways to kind of not to shortcut it, but to do it without having to write down, you know, all of this. Okay, so what I'd like you to do is one of two things. One, pause the video and try these, and then unpause the video and see how you did. Or two, and maybe more helpful right now, depending on your level of understanding, is just follow along with me as I solve these. So up to you what you want to do. Okay, so in doing the first one, what I think is very helpful to do is to re-express it as 9 minus x squared to the 1/2, knowing that something raised to the 1/2 is the same thing as the square root. And as soon as you do that, we can pretty quickly see what our f of x is. It's x to the 1/2, and our g of x is 9 minus x squared. So just for the meantime, f prime of x would be 1/2 x to the negative 1/2, and g prime of x would be minus 2x. So the derivative, and I know that I'm using, there's f and f. Um, for now, let's to not get confused, let's just think of that as k of x. So, so k prime of x is going to be f prime of g of x times g prime of x. So the derivative of the outer composed with the inner times the derivative of the inner. So this equals, well, here's f prime of x, so 1/2, and instead of putting an x, let's put g of x. So 9 minus x squared to the negative 1/2 times g prime of x, negative 2x. Simplifying that a little bit, we get negative 2x over 2 times the square root of 9 minus x squared. Well, how did that just simplify? Um, the minus 2x, 2, 2. And then the 9 minus x squared, it's raised to the negative 1/2. So that's the same thing as flipping it. The negative flips it over into the denominator, and the 1/2 makes it a square root. And so that then can simplify to negative x. Let me rewrite that. That simplifies to negative x over root 9 minus x squared. What about the next one? Well, the next one is actually pretty tricky because it has multiple functions. So the first thing that I would do here is write this as cosine of 2x cubed. I think writing it like that makes it more clear that the outer function is x cubed. The inner function, well, there's actually two inner functions. So the next inner function would be cos of x, and then the innermost function is 2x. Well, f prime of x equals 3x squared. G prime of x equals, well, it's cosine, so negative sine of x, and h prime of x equals 2. So I'm going to take a second and do this on another page so I can have enough space. All right, so now going through this, k prime of x is going to equal f prime of g of h of x times g prime of h of x times h prime of x. Okay, so that equals, well, f prime of x is 3 of x squared, where x is g of h of x. So that's cos of 2x times g prime, well, that's negative sine of x, but instead of x, we're talking about h of x, so sine of 2x, times h prime of x, so times 2. And if we were to rewrite this in a nice way, that's negative 6 times cos squared of 2x times sine of 2x. And I'm going to stop this, and we're going to do a couple more problems in the next video. But also in the next video, what I'm going to do is walk through how I would solve this kind of shorthandedly. So kind of maybe take a second to rewatch this, think about how we used the composition of functions. But in the next video, I'm going to start with showing you the shorthand to this.